you can see, we've got plenty of visitors here today in the class, much more than what we have had in the past. But you all knew that this was happening. We had plenty of notice. So over here we have Mrs. Yang. You know me already, I'm Miss Blakely. We have Mr. Wu, we have Mr. Johnson, and we have Mr. Arn on the far side there, who you met on Friday. And we are here today to introduce our project that we've been telling you about, which is our STEM-based project, so that we're all working together with you. What we want to do today is we would like to take the opportunity for the other teachers to introduce themselves, because you haven't had a lot of time with them yet. And then from there we're going to introduce our design brief that we've been briefly discussing and the situation, so that we know how to move forward from there. Anyone have any questions so far? No? We all knew this was happening, so we're all right with that. Who wants to start?
I'm going to jump in if Mr. Round can log in so that I can use my visual in a second. I need to write. Oh, you've already got it. Wonderful. Thank you. I'll refer to it in a second. I might leave those familiar cars there. People have seen these over the last little while, but good afternoon, everyone. It's a real delight for me to be here with you, especially being that, not just that I helped to come up with the name for the project, but I'm leaving a Year 11 top maths class right now in very capable hands, because there was no way that I was going to miss what's happening today and the launch that we're going to be involved with. Okay? Now, just to give you a bit of background about myself, I went and studied a Bachelor of Education, Bachelor of Science at university, so this whole STEM idea I'm heavily invested in. I'm very keen for you guys to understand why that's worthwhile for you as well. Okay? I said right at the beginning that I'm very excited about this project. I want to give you 3 reasons why I'm excited. Firstly, a bit about me. Secondly, a reason about the project itself. And thirdly, a reason about you. No pressure. Okay, so let me start with me, because that's my starting point for everything, because I'm a very self-centered, egotistical man. No, it's not true. When I was at school, I was fairly good at maths, and that was the end of the story. Like, I was very good at doing all the processes and understanding it, and that sort of came naturally to me, but I had very little appreciation of the power that mathematics has to understand our world and help us to manipulate it as well. You just have to think about the things that you've learned over maths over the last 9-10 years of your schooling. Let's start with this. Say quadratic equations. We've worked with quadratic equations for at least a couple of years. Quadratic equations unlock the path of flying objects through the air. Think about statistical analysis. Statistical analysis is what allows us to take mind-boggling amounts of data and find patterns and meaning and draw conclusions about it. Even the really, really seemingly irrelevant stuff has to do with something. I'll give you an example. Prime numbers. Who knows what a prime number is? I'm not going to ask you to give me an example. I just want to get a show of hands for how much explanation I have to give. Okay, excellent. Thank you. Hands down. For those of you who didn't raise your hands, it's fine. The easiest way to think about a prime number is a number that doesn't divide up nicely. Okay? So, picture a pizza. If I were to be really weird and cut this pizza into 1, 2, 3, 4, 5, 6, 7 pieces, if I count, that number of pieces is really hard to divide up. You can't divide it evenly between 2 people, or 3 people, or 4 people. You can't really divide it up under any meaningful number of people unless you've got 7 of them, or unless you do some cutting. Right? So 7 is prime. Of course, a number which isn't prime, someone will give me an example of a number that's not prime.
8.
8, I had 6. 8's easy, because you can do it into 2 groups of 4, right? So it's not prime, okay? What do primes have to do with anything? They seem like the most, who actually cuts a pizza into 7 pieces? No one, right? But actually, prime numbers are things you use every day, okay? Think about it. Every time you log on to a website, or you buy an app or a song on your phone, or you connect to the wireless, anytime you put a password or a credit card number to something, a prime number is the fuel of the engine that's mathematically keeping your data secure. Every time, actually, there's a single new massive prime number, and that's the only thing that stands between you and all the hackers of the world. Who cares about these prime numbers? Well, I hope you do, right? Even if you don't understand all the things that are happening beneath them. So, I made that discovery about the connection between maths and our world. I made it after I left school, actually when I was training to become a teacher. But you will make that discovery in this course, okay? Which leads me on to my second thing. I'm really excited about, this is my second reason why I'm excited about this course, the nature of the course itself, right? Now, even the very fact that the 4 of us and Mr. Johnson are here in this room is a literal embodiment of the fact that we've been working together, collaborating for months to plan this project and to make it a reality. And that's the way things are in the real world. There aren't clean lines between maths and science and technology, engineering. They're all one. They all fit together. Not only that, but, and this is why I have this visual here, in mainstream maths, you're used to learning things and being challenged to do things like this. Okay, so let's have a look over here. You've been doing, I'm going to pick out the exercise that my class was doing today. Here we go. Okay. No, a bit further. I hope you've done income tax already. Here we go, simple interest. Now, let's pick out a question like this. Okay. If you can read it there, you've seen hundreds of questions like this. Calculate the simple interest earned on an investment, $35,000, 4 years, 3.6%. Okay. Now here's the wonderful thing about this question. You know that there are exactly 3 pieces of information you need to solve this question. And you know because they're the 3 that have been given to you. Now that's nice, that's convenient, it's handy for a formula, but it's not like the real world. In the real world, you don't get told there are 3 pieces of information you need to know, and you need to fit them into these 3 holes. In the real world, you have to work out what the information is that you need to know, and then you have to go and find it, and then you have to work out how to combine it all together. And that's what this course is going to show you and develop the skills that you have for asking questions mathematically and scientifically and design-wise. I had a reason about me, a reason about the structure of the course and the great new way of learning that it introduces. Lastly, a reason about you. I'm so excited when I look around this room because you are the thinkers and doers of the future. The skills that you learn today here in this classroom will shape the world tomorrow. That is intensely exciting for me and for the rest of the teachers on this course. So I'm excited about the project. I hope you guys are too as you discover a bit more about it. Thanks, Owen.
I'll go next. Right, I am Miss Yang. I teach physics and chemistry in the school. And what Mr. Wu said is really true. The physics, chemistry, and the engineering, and even the arts, we all link together in this real world. A bit of my background, why I'm in this project, and why you people are so important. Okay, you people are really important because I got to leave my year 12 class. I'm a winner now. They're really important, but I have to take that one period out to see you people. I'm really excited to be here. Now, a bit of myself. I major in physics. That means I did pure and applied physics in the uni. And not many girls. So girls, yeah, really into engineering, that's really great. Physics is a subject that's required in engineering, so we hope that you picked up this subject, and with your math skills and your technology skills, you're going to face the world and be the future for the we have biomedical engineering. We have so many different courses that's really challenging and very exciting, but we need to get you people interested first. That's why I'm here. And I think Mr. Wu has spoken a lot about the linkages between science and maths and other subjects. And as in school, always interested in problem solving like you people. In those days, we don't have computer. You have the technology. That's why technology is also in one. STEM stands for science, technology, which is really important, and engineering and maths. So in my days, we don't have the computers. We actually run to a library to find anything. You got to actually browse through the encyclopedia. Not like you, all information can be found through your research just at a click of your mouse. But during my time, I spent time in the library to admit as a student. I'm quite a good student, so I went to a library. So I had a scholarship to go into teaching. After choice, actually, I got into other courses as well. The one that interests me the most is engineering and electronic engineering. I think I'm far ahead of my peers at the time. There wasn't a course in the uni at the time. Electrical and electronic engineering. They only have electrical engineering. So I can't take that course. So I'm always passionate about electronics because you use this to make robots, sensor, that's the future. You don't need to drive the car these days. You just press a button, it goes. You don't fly the plane these days, you press a button, it's all programmed. Okay? So I'm like many years ago, I'm already interested in all this. And then at HSC level, I got the opportunity to shake the hands of a Nobel Prize winner. You know who's the Nobel Prize winner of science? Did you know any? Ladies, did you know any lady that's the most famous one? That really have a deep impression in me. She's none other than Marie Curie. Have you heard about her?
Yeah.
Husband's Marie Curie, both are scientists. So, but I didn't get to shake her hands. She's died about 50 because she got radiation. She works with radioisotope and she's exposed to all these radioisotopes, so she got cancer. And I actually got to shake hand with a physics Nobel Prize winner when I'm at HSC. He came to visit my school. That's really great. And he shared the same surname as me. That's a special thing, right? So that makes me really keen to do science and always very passionate to help you people to get interested in science. And I won't bore you. I think Mr. Wu has told you why it's so important as the job future of the world. I'll get Mr. Ang to talk to you about that.
Hello, class and peers. So I'm just going to introduce myself, why I think science is an important thing that you need to know to achieve this project, and also just some interesting facts about me. Okay, so let's begin with an introduction to myself. Mr. Wu and I, we actually went to the same uni. Unfortunately, our timings were a little bit incorrect, so we were never in the same lecture theatre. And I too studied Bachelor of Education and Bachelor of Science, but I didn't major in maths, I majored in chemistry. And I was delighted to study 3 years of chemistry at uni, amongst minoring in physics as well. So they're the two subject areas that I'm actually capable of teaching at this school. Currently I am teaching physics, so hopefully some of you, I'll see you in Year 11 Physics next year. But nonetheless, I'll begin with our project. So as you're aware, Miss Bleakley has already talked to you about what this project may entail, and I'll just begin with where it all came from. So when I have to teach in K9, it's really far, like really far for me. And it's quite challenging to walk from K9 all the way back to the staff room. And the quickest way is actually through the top playground rather than taking the concrete path. And so I would walk through the top playground to arrive at either the G block or to the staff room. And during that journey that I would take, my shoes would get really dirty. They'll get dust on them. If it rains, I'd get mud on them. And that was quite irritating to me. And so I would, sometimes go into the men's toilet and just, wipe it off so my shoes were clean. Right now they're not clean, so don't look at them. I just walk through the top playground. And that's an observation that I made. So I'm going to show you a photo of an area of the top playground. You might recognize the location. Does anyone know where this is?
Yeah. Just outside G230.
Yeah, so that's G230. You can see some grass, you can see some, I don't know what this is, topsoil, dirt. It's terrible for the shoes. And this leads on to this photo, which is in front of G2. Ooh, 1 second. Does anyone know where this is?
G229.
That's G229, so it's right opposite G230. And what happens is the dirt from the G230 runs off when it rains and it pools here. And so when you want to enter this classroom, you have to walk through that puddle. You get mud on your feet, mud in the classroom, slipping hazard, dirty shoes, no one's happy, right? And so this was an issue for me, and I'm like, what could we do? We have to do a STEM project. Why don't we revitalize? Everything just was fitting together. And so I'm like, excellent, my shoes won't get dirty. We can rejuvenate the topsoil of the top playground. I thought it was an excellent opportunity. So that's kind of the basis of where this project came about, dirty shoes, and that was the observation that I made. Now, why is the observation important? I will show you an image. Who here remembers their SRP from year 8? Remember the plant SRP project you had to all complete? It was a compulsory component of year 8. And it's the introduction of the scientific method. Some of you may remember learning the scientific method from year 7. Some of you may remember it from year 8, but I'm going to break it down to you because you'll be doing an experiment that will require for you to use the scientific method. What is the scientific method? It's a procedure, it's a process that allows us to answer questions systematically. And so how does it begin? I'm just going to quickly whiz through this. Here's our baby. He's called Bobby. Why? I don't know. It's just called Bobby. And we first start off with an observation. I observed that my feet were getting dirty as I was walking through the top playground. I made that observation. And then I would form a hypothesis. Does anyone remember from year 8 or year 9 what a hypothesis is?
Yes, prediction.
A prediction. Anything else? Come on, interact with me. Is it a question or is it a statement?
Statement.
Statement. So it's not a question, it's a statement. And a lot of people say that a hypothesis is an educated guess. Would you agree with me on that?
Yes.
I'd like to extend that just a little bit further to say that a hypothesis is making a statement with no evidence, no experimental evidence. And so that's what you'll need to do quite shortly. And so I'm just going to quickly whiz through this for time's sake. We would form a statement of some sort with no experimental evidence. We'll perform an experiment, which you'll be doing shortly. We'll analyze the data, which Mr. Wu will be going through you quite extensively, because you'll be collecting this massive data. Then we'll be reporting our findings. Now this will be through a process of presenting a report, which I'll go through with you how to do. And then we shall invite others to reproduce our results. But because we're a class, because we're a team, we'll have many results which we'll be able to somewhat repeat. And so I'd just like to leave you with the fact that during this course, this project that you'll be all participating in, the scientific method is a tool that you'll be using in your toolbox to achieve certain outcomes. And so hopefully we'll go through it together more in due course. But finally, I shall leave with this image, if I can find my mouse, and that's this. So I took a photo whilst I was on playground duty, and it's this huge truck just dumping bark around, and I'm not sure why we have mountains of bark, but we do. And I think this is a temporary solution to the problem that we have. And so hopefully I won't have to see this ever again. Hopefully I don't have to walk on it and potentially sprain my ankle, which I've almost done. Oh, geez, it was terrible. But anyways,
Mr. Ryan is obviously very disturbed by the state of our playground. It's causing him a lot of upset, as you can see.
Emotional distress, but I'm sure that you as the future problem solvers will be able to deal with it. Sorry, I think I've gone for a bit long, but thank you very much.
That's
You know
all
it
right.
again.
And I think what Mr. Arn has actually just left us with is something that we've already discussed, but it also ties in very nicely. So over the last few weeks, we've been going through the steps of the design process. Everyone remembers this? Yes, we have a nice little diagram. Some of us that are brand new, maybe not, but we will definitely be reiterating it. In the double period that we had last time, we got a sample brief, and then we unpacked it and we developed a research plan. That's what we're going to do with you here today in class all together. Now, that plan or that procedure that Mr. Arn just showed you, Mr. Arn actually might have to do this for me. Can you show us that plan again? And could you also read up maybe for me? That plan actually ties in very nicely with the design process. Now we've come across the design process a couple of times now, and we've identified that the very first step is what? What is the first step in the design process? What is the very first thing that we do? We make an observation. And then that forms our design brief. Good. Can you see exactly what we're doing here? We're making an observation, and then we form a hypothesis. The hypothesis is our design brief. So automatically you can see how Mr. Arn and I didn't even plan this part of the speech, but you can see that his steps are the same as my steps. Okay? So we make a hypothesis, and then we perform an experiment. Now, our experiment, if you like, or we're just drawing similarities here, our process that we need to go through is we need to do a lot of research, and then we need to come up with a viable solution to fix all of the problems that we've identified. Now, in class over the last few weeks, we have gone through a lot of potential issues of the top playground, and we actually brainstormed around and around and around and around in circles about how they all link. So we're going to do that again, but we're going to form our research plan whilst we do that. Sound good? Yeah? Does anybody have any questions at this point? Because I'm going to stop just for a little break while we get this loaded. Does anyone have any questions of any of us? Everyone's very quiet today. This is in fact the
You
quietest
didn't
I've
want
seen.
to know any secret from the teacher?
Yeah, do you want to know anything about us?
About us?
Yes.
The upcoming CAT test. Do you want me to talk a little bit about the
That'd be
CAT
great,
from
sir.
Japan? And
Yep.
Yeah, that'd
look,
be
firstly,
fantastic.
can I congratulate you and welcome you to the course. I have a very strong interest in the whole STEM thing for a variety of different reasons, but chief amongst them is at the beginning of last year I was doing some work at the Board of Studies, and the Board of Studies, where you've got all these educators that meet, and they're the people that set your curriculum, and they set your exams for the high school certificate and all that sort of stuff. So at that particular meeting they were talking about the way the world is changing very, very rapidly, and the fact that over the years we've produced a whole lot of people who are very good at running economies and things like that, but actually people who make things, put things together and manage them, we're starting to run out. And we need to develop a lot more people that can work in that area. And really, it's in the area of science, technology, engineering and maths. And one of the things they talked about was the same thing where Mr. Wu started from, is the idea that these things should be combined. And I'll tell you, I think within a couple of years, maybe even by the time some of you people get to HSC, there will be a new course that actually looks at bringing all of this stuff together. So that was important for me. And then I had dinner one night with the bloke that's the Vice-Chancellor at the University of Sydney, and he said, we've just been left $20 million by a philanthropist. Who knows what that big long word philanthropist means? Fantastic. What a great answer. That's exactly right. Somebody who leaves it for a given area. It's a fantastic answer. And that money was put aside at the University of Sydney entirely for STEM, because that particular person could see that as being a need for our future and the way to go. And then when I was overseas last year, I got this lovely email from Mr. Townsend saying, but a whole group of teachers are interested in putting together a STEM class. And I thought, what a great opportunity. Really fantastic opportunity, give you a leg up into a whole range of different things, and a really positive way. And you know, it's not just in Sydney that's happening. And at 2 o'clock yesterday afternoon, I was doing a little bit of gardening, and I came back inside and I found that the thing was going ping, ping, ping on my phone, and a number of emails had come in. And one of them was from Mr. Sagani from the Koyo School, which is a senior secondary school in Nagoya. And we had some of those people out visiting. Over there in Nagoya, they've just started a new course called Global Science. And really, I think this course could be almost called STEM. And he wanted to know whether or not we'd be interested in having some sort of connection with their particular school. He's talking about video conferencing, and at the moment, that's as far as it's gone, because it came through at 2 o'clock yesterday afternoon. But I think there's an opportunity for us to perhaps look at what we're doing here and perhaps share it with some folk over in Japan. And you start to see that there's a whole global link with the STEM stuff as well. So it's a good thing to get involved in. I think it's marvellous that you're bringing the disciplines together and using them in a very positive way. And it's nice to see a nice balance of girls and boys in here too, because I think increasingly that's something we're starting to see in the universities as well, in the area of engineering. I went to the same university that Mr. Wu and Mr. Rahn did, but I don't think they were born when I went to university there. And I used to walk through the engineering faculty to make my way up to the other side of the university. And when you walk through engineering, you never saw a woman. You never did. And that has changed really dramatically, and for the better, in a really positive way. So I'll pause there, congratulate you, and welcome you on board in an official sense, and say I'm really looking forward to what's going on.